Hi, I'm Plebhash, and this is episode 3 of the Stratum V2 Explained series. Today we're gonna finally dive into Stratum V2, which gives the name for this series. So, first of all, acknowledgements. The series is based on Gabriele Vernetti's Master Thesis at Politecnico Di Torino. I highly recommend that you go on GitHub and check out the original PDF. There's a lot of knowledge condensed on this document. I'm just basically trying to relay it in a spoken form with some visuals here to you, but the original comes from this, and all credit go to Gabriele. So what is Stratum V2? It was initially proposed in 2019 by Pavel Moravec, Jan Kapec, both from Brains, in collaboration with Matt Corallo. It was proposed to address the limitations and shortcomings of Stratum V1, as we already saw in episode 2 of this series. So here's a picture of Pavel, Jan, and Matt. And so how does Stratum V2 work? We have the notion of roles. Roles are involved in data flow and can be classified as either downstream or upstream in relation to each other. So we have 5 roles, basically: mining device, pool service, mining proxy, template provider, and a job declarator. A mining device is the ASIC, right? It's the physical hardware that carries out the hashing process. It is considered to be the most downstream role. The pool service is the role where the actual hash rate produced by the mining devices is consumed. It is considered the most upstream role. Proxy, it's situated between the mining device and the pool service. It handles message coordination and aggregation. In relation to the mining device, it is considered upstream, while in relation to the pool service, it is considered downstream. The template provider is basically a Bitcoin client, a Bitcoin node, that's responsible for generating custom block templates. These templates are then sent to the job declarator for mining purposes. The job declarator receives block templates from the template provider and declares use of the template with the pool using the job declaration protocol, which we're going to look in detail later. Then it distributes the jobs to the mining proxies using the job distribution protocol. This role will often be a built-in part of a mining proxy. So here's a visual representation of the different roles involved in Stratum V2. So here on the left we have a few mining devices, and they're all communicating with a proxy, and together they form a mining farm, right? So here the proxy is doing this kind of a fan-in pattern where it aggregates the hash rate coming from the different mining devices, and then it uses one single connection with the pool to send the aggregate of all these different hash rates to the pool. And we can also see mining devices are the most downstream roles, pool is the most upstream roles. And it's important to note that this is not the only possible mining farm or mining setup configuration that Stratum V2 allows for. This is just an example, right? But there could be different configurations using the roles. And yeah, this picture credit goes to Galaxy Digital. So let's look into the protocols. There are 3 distinct subprotocols needed in order to fully use all the features proposed in Stratum V2. The mining protocol, the job distribution protocol, and the template distribution protocol. The mining protocol is the primary protocol for mining and serves as the direct successor to Stratum V1. It enables communication between a mining device and its upstream node. It could be a pool or a proxy. This protocol is essential and it must be implemented in all mining scenarios. In cases where a miner or a pool does not support transaction selection, the mining protocol is the only protocol used. The protocol defines 3 types of communication channels: standard, extended, and group channels. Standard channels do not manipulate the Merkle path or the Coinbase transaction. So that greatly simplifies the communication required between the mining device and the upstream nodes. Extended channels they allow for extensive control over the search space so that miners can implement advanced use cases. For example, translation between Stratum V1 and Stratum V2, difficulty aggregation, custom search space splitting, etc. And group channels are simply collections of standard channels that are opened within a particular connection so that they can be addressed inside this channel. So the job distribution protocol is utilized by a miner or a mining farm to negotiate a block template with a pool. The results of this negotiation can be reused for all mining connections to the pool, reducing the computational intensity. In other words, a single negotiation can be applied to an entire mining farm or even multiple farms with a large number of devices, leading to greater efficiency. Template distribution protocol. It facilitates obtaining information about the next block from Bitcoin Core. It is designed to replace get block template with a more efficient and easier to implement solution for those incorporating other aspects of Stratum V2 into their systems. So let's look into security, protocol security. Stratum V2 uses authenticated encryption with associated data, or AEAD, to provide both confidentiality and integrity for all Stratum V2 communication channels. Before opening any Stratum V2 channel for mining, the clients must first initiate the cryptographic session state that is used to encrypt all messages sent between themselves and the servers. Thus, the cryptographic session state is independent of the Stratum V2 messaging conventions. Stratum V2 also introduces the optional use of a particular handshake protocol based on the noise protocol framework. The client and the server establish secure communication using a Diffie-Hellman key agreement. And using a handshake protocol to establish a secure communication is optional on a local network. So for example, there's local mining devices talking to a local mining proxy. They're all in a local area network in the same farm. And if this local area network is assumed to be safe, if there's no reason to believe that an attacker could have infiltrated this network, then the handshake protocol is optional there. However, for remote access to upstream nodes, be it pool mining services or job negotiating services, template distributors, it is mandatory that the handshake protocol and all the encryption is established so that all the communication happens in a secure manner. Binary framing. The Stratum V2 protocol is binary with fixed message framing. Each message begins with an extension type, message type, and a message length, followed by a variable length message or the message payload. So here's a table with a summary of the binary framing. So first we have the extension type, message length. They're all on specific binary types. And we have the actual message payload. Transaction selection. In Stratum V1, the selection of the transactions to be inserted in the block templates is a pool responsibility. They're the only entities who took the valid Bitcoin transactions from the main mempool and decide the ones that will be mined in the next block. And since pools are single entities, they can be attacked by governments. So this is not ideal for the censorship resistance property of the Bitcoin network as a whole. So that's in summary, this is a flaw in Stratum V1. So with Stratum V2, miners now have the ability to choose their own work, to choose their own transaction set, making the mining process more decentralized. This is implemented separately from the main mining protocol as described previously and is optional for pools and miners. It is important to note, however, that the pool needs to agree with the block templates proposed by the miners. This negotiation happens over the job distribution protocol. If a miner submits shares from a block template that the pool did not agree with, they will be rejected and the work will be lost. So now let's look into the differences between Stratum V1 and Stratum V2. Bandwidth consumption. The use of a binary protocol instead of a text-based protocol significantly reduces bandwidth consumption. In Stratum V1, like we saw previously, messages are readable by humans. They're text-based messages, which makes them unnecessarily large, or approximately 2 or 3 times bigger than they need to be. In Stratum V2, these messages are minimized to their essential size. And also, Stratum V1 has some unnecessary messages like mining subscribe, which have been eliminated in Stratum V2. So here's an example. In Stratum V1, a typical share submission message is approximately 100 bytes, whereas in Stratum V2, a typical share submission message is 32 bytes without encryption and 48 bytes with encryption. So that's less than half of the size of the same message in Stratum V1. Server CPU load. Thanks to the introduction of standard and group channels, Stratum V2 achieves a reduction in server and CPU load by implementing header-only mining for end devices. This implies that the Merkle route, which was previously handled by end devices, is now always provided by an upstream node. Consequently, the computational load on end devices is lighter, since there's no need to perform any coin-based modifications. This simplifies the work for miners, and at the same time significantly lightens the workload required for work validation on the server side. Header-only mining. Stratum V2 introduces the possibility for miners to open standard mining channels that skip coin-based transaction manipulation. In other words, end mining devices don't need to do any extra nonce or Merkle path handling. This process is called header-only mining. The size of the search space for a device that's doing header-only mining with a fixed end time field is 2 to the power of nonce bits, which are 32, plus version rolling bits, which are 16, which results in 280 terahashes. This is a guaranteed search space before end time rolling. The client that opens a particular standard channel owns the entire assigned search space and can split it further, for example, between multiple hashing boards or individual chips, if necessary. Job distribution latency. In Stratum V1, mining pool servers send jobs to miners containing both the prev hash, which is the hash of the parent block, and the Merkle root of the transaction list to be included in the next block. That's all done using the mining notify message on Stratum V1. These two pieces of data are not separable. So there's a heavy and slow data transfer necessary to distribute new jobs as soon as a new block with a new prev hash has been found and propagated. So this is a limitation in Stratum V1. In Stratum V2, it is possible to separate the prev hash from the rest of the predefined block data, which allows for the block data to be sent before a new prev hash is available. As a result, the new prev hash message can be sent on its own as soon as a valid block is found. And this transmission can occur much faster because the message does not include heavier data. This enables miners to begin working on new jobs more quickly than they could with Stratum V1. This also reduces the possibility for empty blocks being mined. Man-in-the-middle attack prevention. So the usage of encryption on Stratum V2 addresses the security aspects of all communication that occur between miners and pool servers. It provides both confidentiality and integrity for all the data being transferred. And it also prevents potential adversaries from sniffing share submission data to identify particular miners, thus maintaining the privacy of miners, and also protecting them against hash rate hijacking. Multiplexing. In Stratum V2, there can theoretically be as many as 2 to the power of 32, which means around 4.3 billion open channels within a single physical connection, or a TCP socket, to an upstream Stratum node. These channels are independent and have unique channel IDs, meaning that many devices can simultaneously receive different job assignments using the same connection, saving on infrastructure costs. At the same time, the channels may all share some information for greater efficiency, such as when a new prev hash is broadcasted. Native version rolling. Each Bitcoin block header contains a version field whose bits can be freely used to extend the search space for a miner. Rolling the version bits can greatly reduce the frequency with which new jobs need to be distributed. And it's already a common technology on BIP 320. With Stratum V2, version rolling becomes a native part of the mining protocol. So now let's look into the current implementations of Stratum V2. Like we said, Stratum V2 was proposed by Brains engineers. So the first implementation came from the Brains team. They developed the first implementation in 2020, and it was incorporated into the Brains OS firmware. After publishing the first implementation of Stratum V2, the Brains team decided to pass the future development of the protocol to someone who was external to their business. Or in other words, they just wanted to decentralize the development process of Stratum V2. So Stratum Reference Implementation, or SRI. During 2020, a new group of independent developers started to work on a fully open source implementation of Stratum V2 called SRI. The purpose of SRI group is to use the Stratum V2 specifications to build a community-based implementation with the aim to discuss and open the development with as many people in the Bitcoin community as possible. The SRI group has also been expanding the Stratum V2 features already covered in the Brains implementation. So in order to check out Stratum Reference Implementation, if you want to see the docs, the specs, tutorials, blog, you can check stratumprotocol.org. And here you're going to find all that cool stuff. Specs, documentation, some tutorials. And for code and issues and pull requests, you can refer to the GitHub repository where the code lives, right? So it's a Rust code base, and you can check. Basically, I would advise you to check the releases. That's the first thing you should check. The main branch is where the releases are merged, and there's also the dev branch where development takes place. So most of the pull requests and the new features are added as pull requests to the dev branch. And then when they get into releases, they go into the main branch. So that's it for this episode. On the next episode, we're going to look into Stratum Reference Implementation in details, how it works, and future ideas. So yeah, thanks for watching.